Hello student, this video is based on the activity which represent the illustration of the central limit theorem. So before we'll start with the activity, firstly I'll just give you a brief idea about the central limit theorem. So the central limit theorem basically tells us that every distribution tends to the normal distribution if the sample size is very large. Okay, so if we go through the statement of the central limit theorem, then it states that if x bar is a mean of the random sample of size n taken from a population with mean mu and finite variance sigma square, then the limiting form of the distribution will follow normal distribution with mean 0 and variance 1. Basically, the general result for the normal distribution is that if t is any statistic, basically as a function of random sample observation, then t minus expectation of t upon the square root of variance of t, right? It will always follow normal distribution with mean 0 and variance 1. Okay, and if the sample size is very large, we can also say that t will follow normal distribution with the mean expectation of t and variance as a variance of t only. Okay, so what does it mean? It means that it implies that x bar will follow normal distribution with mean mu and variance sigma square upon n. Okay, so basically it states that when the sample size is very large, like if x1 x2 so on xn with a random sample observation taken from the population, then what is the sample mean x bar? X bar is x1 plus x2 plus so on xn divided by the sample size, that is n. This x bar will follow the normal distribution where expectation of x bar, we know that sample mean is the unbiased estimator of the population mean, and if we calculate the variance of x bar, it comes out to be sigma square upon n. Okay, that means according to the central limit theorem that x bar will follow normal distribution whose mean is mu and variance is sigma square upon n. So in this particular activity we are going to perform the same thing. So what will happen here? So in this case we are going to consider data of around if you see the number of entries, so the data containing about 1749 entries, which simply represent the weight of the students, and on the basis of these entries we have constructed about 100 samples where each sample containing around 500 entries, right? So here the sample size is 500, and based on this sample size we have calculated the sample mean. Okay, so basically what is our random variable here? Here the random variable is x bar. So what I want to prove that this sample mean will follow the normal distribution. This is what we are going to study within this particular activity. So the first step is we are going to select this data of the sample means. So like in this case the data is in the form of a row only, so to select this entire row we have used the option Control Shift and right arrow. Okay, and then we copy this particular data and we are going to paste it here, but the data is given in the row format and I want to paste it in a column format, so I'm going to use the special paste option, Control plus Alt plus V. So when we click this option, then we get this particular option here, so I'm using the option of transpose. Okay, so it will convert the row data into column data, right? So what I have used the command here, let me show you here. So here we are having a data in the row format, right? The data is in a row format. Okay, so how do we select this data? So we are using control plus shift plus right arrow. So when we choose this particular option, it will select the entire data, right? Now this paste special option is, for that we are going to select the key Control plus Alt plus V. Okay, and then we need to select the option of a transpose, so it will convert the data from row data to the column data. Okay, so this is the command we have used here. So you can see here now the data is pasted in the form of column. So I named this random variable as say x, but basically it represent a x bar. Okay, so what I want to do, that I want to prove here that the sample mean will follow normal distribution whose mean is equal to the population mean and whose variance is equal to the variance of the population but divided by square root of n. What is n? N is the sample size. Like in this case, what is our sample size? Here our sample size is, here we have considered a sample of size 500. Okay, and on the basis of that only we have calculated sample mean, right? Okay, so to calculate the probability, now again like the previous activity, we have to draw the normal probability for the same, but again in this case the data is given in a discrete form. So if we want to calculate the maximum or the minimum value, I firstly am going to sort this data in a increasing or the decreasing order. If we sort it into increasing orders, then we find that its minimum value is 63.1514, and if we want to see the maximum value, then the maximum value, for that I am going to sort this data in a decreasing order. So I choose the option of data and then we choose the option largest to smallest. So we find that its largest value is 66.1121, right? So basically all the values are lies between 63 to 66, and because the data is discrete, firstly we need to convert it into interval form, right? And we need to calculate the corresponding frequency, but we need at least 10 to 15 entries so that we can get an idea about the type of the distribution here, right? So for that part, how many partition is required, like how many partitions, if for example if for a fixed partition, what is the formula? The number of partition is equal to the width size is equal to b minus a upon n. So b is the maximum value, is the minimum value, divided by how many partition we are expected, right? Like in this case we have a 66 and the smallest value is 63. I'm simply taking the integral value. So for example, if I am expecting 10 partition, so it means that 3 by 10 we need to consider 0.3 as the width size. Okay, if we want more, say 15, then we can say b minus a upon n, like 66 minus 63 divided by say 15, so it will gives us 3 upon 15, its value is 0.2. okay, so if we need in between, then we can select 0.25 also. Okay, so for example, if I choose the width size as 0.2, then I'm choosing the bin value because the smallest value is 63, so automatically it will be covered in 63.2. So I'm starting with 63.2, then 63.4, and up to, we need value up to 66.2, so 66.2, right? Okay, so we have decided the bin here. Now the next step is we need to find out the corresponding frequency. Okay, so for what we are going to do, like in the previous activity we have discussed, that to get the frequency we go to the option of data, then we need to select the option of data analysis, select the option of histogram. So here we need the values from, because here we have taken 100 sample observations, so control shift and down key, so all the 100 observations are selected. So what is the bin value? So for bin value I'm going to consider this particular column, control shift down, so all these selected, and I'm expecting its output in the very next column. So for that I'm selecting G column only. So when I select OK, so you will get the frequency. So because the maximum value is 66.121, so no more option is there, so I'm deleting this particular part. Also this column is not required, so I'm going to delete this one. Okay, so if we calculate the sum of the frequencies, so we can use the formula of sum here, control shift down, bracket close, so the sum is 100. Okay, so frequency is known, so on the basis of that we can calculate the probability. Like we have discussed that if the frequency is known, then how do we calculate the probability? Okay, like in the previous part we have discussed that if we toss a coin, 100 times, so how many times we have tossed a coin? 100 times. So out of these 100 attempt, say we are getting the number of times we get a heads, we get 57 time head. So what is the probability? So probability is number of time we get a head divided by total number of time we have performed the experiment. So its probability is 0.57. Okay, so it is the frequency of the occurrence of event divided by the total frequency. That means what is the formula of probability? Frequency of the event occur divided by the total sum of the frequency, or we used to denote it with a capital letter N, right? So if we use this formula, so how can we calculate the probability? This is equal to frequency divided by sum, that is 100. Okay, so to get all other probabilities, I simply drag this column, so we can get the probability as, okay, and you can see here the sum of all the probability is 1 only. So this is the actual probability on the basis of the data. Now the next step is we need to calculate the probability using normal distribution. Okay, so like we have discussed in the previous activity, right, that if the data is discrete, then how do we calculate the probability for the normal distribution? So if I want to calculate, say, probability at a point x equal to a, so it can be written as a is less than equal to x is less than equal to a. So if I want to convert this data into continuous form, we need a continuity correction factor. Continuity correction factor, which is denoted by letter delta. And what is delta? That is equal to the width between the two consecutive value divided by 2. Like in this case, what is the width? Width is the 0.2. Okay, so here the width is 0.2, so in this case this is 0.2 divided by 2, so its value is 0.1. Okay, so how do we convert it into continuous form? A minus delta, a plus delta. Okay, so basically this is the discrete data. So with the help of the continuous data, we have converted into continuous form. Okay, so now this is in a continuous form, so I am assuming it, let it be say A and let it be say B. So if in case of normal distribution, if we have a continuous data, how can we calculate the probability? Firstly, we need to subtract the population mean divided by the standard deviation of the population, and upper limit also minus mean divided by the standard deviation. So if we denote it as a capital A and this is as capital B, so this is cumulative distribution function, right? That is f of B minus f of A, right? Because the CDF formula of f of x is probability x is less than or equal to x. Okay, so the explanation of the same we have already discussed in our previous activity also. I just simply try to remind you. Okay, but like we have discussed here in a central limit theorem, in the central limit theorem the mean of the population is mu, but the variance of the population is sigma square by n. So what about standard deviation? Standard deviation is sigma upon square root of n. Okay, so the first step is we need to calculate the mean of the population. So I am expecting mean of the population, so we need to consider the entire data because this is the sample here. Okay, so we need the actual data, so I'm taking the average of the actual population. So what is the population here? So this is the population data here. I'm going to select control shift down key. This is 1749 entries are there, so that will give us the mean. And what about the standard deviation of the population? So standard deviation of the population is, so again we need to come to the population data, control shift down key, and here we can get the standard deviation. Okay, so what is the standard deviation? So we have come to the actual population data, we have selected the entire data, right? But for this particular, in central limit theorem, the standard deviation is, in central limit theorem the standard deviation will be sigma upon square root of n, because if the variance is sigma square by n, population variance, right, this is variance of x bar, then what about standard deviation? Standard deviation of x bar, this is square root of variance, and square root of variance is sigma upon square root of n. Okay, so we need to divide this by n so that we can get the standard deviation of this. So it is equal to the square root of this value. So again we calculate the square root, the symbol is sqrt function, and we need to select for what value we need to calculate, right? So it means we can, all the command of calculator we can use easily here. Okay, basically the formula is sigma upon square root of n, sorry, this value divided by square root of n is, what is n? So basically in this particular activity for the sample mean, so we have taken I think around 500 observation, control shift down. So how many observation we have considered? 500 from 2 to 501. Okay, so what is our n here? Here n is 500. Okay, so mean is known, standard deviation is known, so we are using the formula of normal distribution. What is that? Normal distribution. Here what is our x? This is our x, but for the upper limit we need to add the continuity correction, that is 0.1. What is our mean? This is mean, we are going to add this dollar sign so that we can fix this particular box. And for standard deviation we are going to use this, again I fix this box, so we add a dollar sign here, and then we need to consider the cumulative frequency, so we use the command of crew. Now copy this formula minus, we are going to subtract here. Okay, so like I have already explained here, that how do we calculate the probability here. So for probability, so what is your x upper limit minus lower limit, right? So what is your b here? Here for b, the x is this one, this b is a plus delta, so it means that this is normal distribution if I want to write in the form of command. So what is our x? It is b. What is b? It is a plus delta. What is mean? Mean is mu. What is standard deviation? It is sigma. And because we have calculated the cumulative distribution, so we use the command true. minus lower limit means again normal distribution. Now what is your lower limit? A containing A, and what is A? It is A minus delta, mean is mu, standard deviation is sigma, and true for the cumulative frequency, right? But here our standard deviation is sigma upon square root of n, so we have considered this as our standard deviation and mean as a population mean. Okay, so this is the formula we have used here. Upper limit minus lower limit. So this is the formula. So if we drag this value, then we can get all other probabilities also. Of course we need to eliminate this part, right? So you can see here, if we take the sum, its approximately value is 1 only, right? And now this is the actual normal probability, okay, and this is the actual probability, okay. So if we calculate the difference between them, although the difference is a bit quite because we have taken a sample of 500 only, so if we want to see the error, this is equal to absolute value of this minus this. So you can see here the difference is not, it is 0 point something only, so it means that the values are very close. But to get more accurate idea, we can plot this data. Control shift down, we have selected first column, then probability, release shift, and then control shift down, release shift, select this box, control shift down key, and then click on insert. There is option of recommended chart, and then we can select even the line graph, or we can select the column graph. So you can see here, this orange bar represent the normal curve and this blue bar represent the actual probability, right? Although the sample size is not very big, but still you can see here the nature is approximately normal only, okay. To get more accurate idea, so we can also choose the option of a line graph also. So you can see here the graph is approximately normal, nearby normal only, okay. So what is the property here? That x bar, that is sample mean follow normal distribution with the mean is equal to the population mean, and the variance is sigma square by n, right? If we want to check this particular property, okay, let us calculate the mean of this sample which we have calculated here. Mean of the sample, I am considering mean of a sample, let it be denoted by s. So we calculate average, control shift down, and if we calculate standard deviation of a sample sorry, so we need to use the formula of standard deviation of sample, because here we are using sample only, so I'm choosing the formula of sample standard deviation. So selecting this data, control shift down key, bracket close. So you can see here that the difference between the mean value, they are approximately same, and even the standard deviation, they are also approximately same. So which actually verify the result that this particular data follow normal distribution, okay. So this is all about this activity, and if you have any doubt, then you can post your query. I'll try to provide you the solution of the same. Thank you. That's all. Have a nice day.